In the previous course, we went through creating materials with shaders. We used only one color or just a single value to describe material's roughness, subsurface scattering amount, and all the other components. And well, they looked nice, but they were definitely lacking some realism. In our world, nothing is perfectly glossy, transparent, or clean. Thanks to different textures, we can add some variety to the surface of the object and make it look more natural, no matter if we're texturing the stylized or realistic model. Let's talk about texture types now. There are two types of textures: procedural textures and images. Procedural textures are computer-generated images created using algorithms and mathematical formulas. These textures can be seamlessly repeated and easily adjusted to change their appearance. In Blender, we have a few procedural textures to choose from. So let's press Shift-A, Texture, and there's a whole list of textures you can use. We will be making 3 different materials using these procedural textures later in the course. Now let's talk about image textures. Image texture is just an image file generated in a different program, painted in Blender, downloaded from the internet, or a photo you took. But we can also use animated image sequences or even videos. Let's import the texture from the folder containing this lesson's files. You can do it by dragging the texture over the shader editor or by pressing Shift-A, Texture, Image Texture in the shader editor. If you will use an image sequence or video file for your textures, then you can change the type by clicking on this drop-down and selecting the type. For this course though, we'll use image textures, so let's stay with the default. Let's connect our texture to the shader and see what will happen. For now, we'll plug it to the base color input and we can see the texture on our models because they are sharing the same material. Some of them look okay, but custom-made model is looking, well, not very good. It's because we need to tell Blender how to project this texture onto the object surface. In other words, we need to provide the texture coordinates. For custom objects like this, we need to make something what is called UV unwrapping, and it is a process of creating a 2D representation of a 3D model. I prepared the UVs for this model and now we'll switch the collection visibility, and here we have the unwrapped model. But to see the UVs, we need to go to the UV Editor tab. After selecting everything on the right, all the UVs were selected too. Let's move it. The texture is moving on the object too. This is how we tell Blender how to apply the texture onto the object, and we'll unwrap a model later in the course, so we'll talk more about it. Let's switch back to the Shading tab. UVs aren't the only way to set the texture placement on an object. Sometimes you want to use different coordinates than UVs. To do this, you can add a node called Texture Coordinate, or click on the texture and then press Ctrl-T. You can see that actually 2 nodes were added, and it's because in some cases we want to manipulate texture size or location and rotation. You can also add this node by hand by pressing Shift-A, Vector, and Mapping. We can also see that both of these nodes were connected to the blue socket, and we'll explain it later in the chapter. But a blue input is a vector input, and in this case, it tells the texture coordinates to our texture. We can see a few different types of texture coordinates. Let's quickly describe what they're doing. We will be connecting each of these to the mapping vector input. Generated might be called triplanar projection or box mapping. It uses the object's internal coordinates. This is ideal for procedural textures. We can see a lot of stretching here because for now the texture is projected from the top, so let's go to the texture projection method in the texture options and select box. Now it looks way better, but we see a lot of seams, so to avoid that, we can use the blend factor. Let's increase it and you can see that seams are blended, so that's a great way to add the texture without unwrapping the object. Normal uses the direction of the surface normals to map the texture, usually not used too often. UV uses the UV map, which is the flat representation of your 3D object. This is the most precise and common way to place textures, especially for detailed and complex models. Object uses the coordinates from the object itself. It matches the scale of the texture on all objects that have their scale applied. It can also use another object's coordinates for the texture mapping, and it's often used with empty. If you animate the empty, the texture will move too. Similar to the generated method, we'll be using that a lot. For the camera, the texture is mapped based on the camera's perspective. So let's switch back to flat projection, and you can see that the texture is facing the camera. Not really the most useful one, but might be used in effects like lens flare or whenever we want to texture to be facing the camera. Window is similar to the camera projection, though it's stretched a little bit more. With reflection, the texture is mapped based on how light reflects off the surface, simulating a mirror-like effect. In the whole course, we'll be using the generated, UV, and object coordinates the most, as they are the most useful and you can do almost everything with them. Now, let's see what does the mapping node do. And it is pretty straightforward. We have location, rotation, and scale. With location, you can move the texture in each axis. With rotation, you can rotate the texture, and with scale, resize it. There's one thing that might sound a little bit tricky. If you want to make the texture smaller, you actually need to type in the bigger value, so let's do that now. So now you can see that the texture is repeating a few times, what means that it is smaller. If you want to do any transform on all axes at the same time, simply click the first one and then drag your mouse over the rest and type the value or move your mouse to the left or right. There are also some options in the type dropdown, but we'll be using the point only as it is the most common to use with textures. This option allows the transform to be applied differently depending on the semantic type of input. Now, when we know something about textures and texture coordinates, let's take a look at the socket's colors and what they mean.